Hello. Hello. Can you see the notebook?
No, sir.
No? You cannot see the one note? Hmm? So yesterday what we are doing? This one, right? Limit using sequential criteria. So have you solved it? This problem? Have you solved it or not? Saurabh Kumar? Saurabh Kumar?
Yes, sir.
So have you solved this problem?
No, sir.
Why? So what you have to do here? What you have to do? So what is given? That f of x equals to 1 by x, x not equals to 0, right? Now you have to check. Now you have to check. What you have to check? The limit x tends to 0 f of x. Limit x tends to 0 f of x
Not defined, sir.
does not exist. So how will check? So in last class what I have told you, that in order to check that limit does not exist, what you have to do? What you have to do? So in sequential criteria is useful when you want to show the limit does not exist. So what you have to do? I have given you two approach, right? One of them is that suppose some sequence converges to 0, but its image sequence f of, so we have to see sub cn converges to 0 because we want to check at 0 point. So cn should converge to 0, but f of cn is divergent. That is one approach. Another one approach is, so suppose you have to choose two sequence which converges to 0, but f of an, this sequence should converge to different limit. This is another approach in order to show that limit does not exist. Is it clear to all of you? So when you want to show that limit does not exist, sequential criteria is useful. So how will show here? So you use this one. So can you see one sequence which converges to 0, but its image sequence does not converge, diverge? That means the limit does not exist. Yesterday we have discussed. You see, Yeah, see. Suppose you have to show limit extends to c, f of x does not exist. What you have to show? That means you have to choose two sequence which converges to c, but their image, that sequence are different. And another one is if some sequence converges to c, but its image sequence is diverged. If you cancel one of them, that means the limit does not exist. So can you give one example of this sequence? For this example, what will be the example? What will be the sequence? What will be the sequence? Anyone? That means you have not studied, huh? Anyone? Swastik Misra? Swastik Misra? Swastik Misra?
Yes, sir.
So what sequence we have to choose?
Sorry, sir. I didn't join the last class, so
But you have studied limit, right?
yes, sir.
So what you have to choose limit, right? In order to limit does not exist, what you have to choose? Two ways. Either you have to choose two sequence which converges to zero, but their limit does not converge to same limit. This one approach, because here zero is there. Another one, if some sequence converges to zero, but f of Cn is divergent. So what you should choose as Cn? What you should choose as Cn? You have already studied sequence, right? You have already studied sequence, and we are studying limit using sequence first because you already know. In the last class also I have told that in order to limit extension f of x does not exist, that means you have to show some sequence which converges to this c, but f of Cn is divergent. That means this limit does not exist. And this is very simple example. So what you have to choose the sequence Cn. Can you give one example of sequence which converges to zero?
1 by x.
I mean Cn equals to 1 by n, right? So Cn tends to 0. What about f of Cn? What about f of Cn? What about f of Cn?
1 by c.
That is, what is the value?
N.
N. So does this sequence converge f of Cn?
Diverge.
So
divergent.
so that I am asking from yesterday. Now you have understood? Now you have understood?
Yes.
So limit extends to 0, f of x does not exist. Is it clear? You need more example? Is it clear or not? So when you have to show that limit does not exist, in that case, this criteria will be useful. Okay. Suppose f of x sin 1 by x not equals to 0. Okay. So does this limit exist? Example. What will be your answer?
No, sir.
How you show?
Exists
1/0 form.
sign
No, no.
infinitive.
So you have to choose
Because
you have
sir,
to
we
choose.
take a Cn.
So we have to choose two sequence. Okay.
Yes, sir.
So such that you have to choose an and bn, which converges to
Which converts zero.
which 0. And but f of an and f of bn
Is divergent.
means it converges to different limit, not same.
Yes, sir. Yes, sir.
Because you have studied that if a sequence exists, its limit should be unique. For a convergent sequence, limit should be unique, right? For a convergent sequence, limit should be unique. So this is one of the approach. So what sequence you will choose for this to show that limit does not exist? Hmm? You know the answer on, just try. You know all the various values of sine, huh? Suppose an equals to your 1 by n pi. Okay? N is your 1 by n pi. So this sequence goes to this sequence goes to this sequence goes to
Infinity.
this sequence goes to infinity.
Sir, zero.
Zero.
0.
Zero.
So what about f of an? This sequence is what?
It's sine and pi. It's sine and pi.
Sine n pi. Right? So sequence will be of sine pi, sine 2 pi,
Sine 2 pi.
sine 3 pi. So how does it converge?
Equal to zero.
It converges to 0.
Zero.
So now you have to choose another sequence which also converges to 0, but its image sequence should not converge to 0. It should converge to some other value. That means the limit does not exist. So can you give another example of other sequence bn? What you have to choose? Bn.
Sir, 1 upon n pi by 2.
1 upon n pi by 2. So how it will converge? So give some like odd or even, right? Okay. Suppose you are almost like you want to set this one. This one you are saying?
Yes, sir.
So what this sequence converts?
For n equals to infinity, it's also converts to zero.
So this is bn, just bn sequence. This should converge to 0.
Zero.
And what about f of bn?
Sir, sine 2n plus 1 pi by 2.
So what is value?
Sine pi by 2, sine 3 pi by 2.
So what it goes? Sine
1.
pi
1,
by
1.
2, sine 3 pi by 2.
Sine 5 pi by 2.
So how it goes? F of bn
1.
1. So we have seen that two sequence both converges to 0, but their image sequence for this example does not converge to the same limit. So f of an you have seen here converges to 0, f of bn here converges to 1. So limit x tends to 0 f of x does not exist. So I have given you two examples where I have used first this criteria, and in another one I have used this
Sir,
criteria.
sir,
Hmm.
at the place of an and bn, sir, we choose any function.
So okay, so you have to see in the question that x tends to where, you know, you have
0.
to, here it is given 0. Suppose in the exam some values, so in the abstract I have written that limit x tends to c fx exist or not. Suppose this is your question, right? What is
Yes,
c
sir.
here? So you have to choose sequence, okay, some
Which converts
sequence
to C.
which converges to c. So this sequential criteria I told is useful when limit does not exist, okay.
Sir, I want to say, sir, we can take any sequence C and which converts to C.
Yes, any arbitrary sequence. See, in order to exist the limit, there you have to choose any arbitrary sequence. But when you say the limit does not exist, you have to choose particular sequence. Okay.
Sir, in previous question, sir, in the question of sin 1 by x,
Hmm.
sir, we take a Cn equals to 1 by n,
Hmm.
An equal to 1 by n,
Hmm.
and so then why we did not take a Bn equals to 1 by 2n?
Where?
Sir, sin 1 by x वाले question में.
Yeah. Then see here we have to see that I told you that sequential criteria is useful when you want to show that limit does not exist. That means either here, okay, either here you have to choose something, okay, either here you have to choose carefully what is your Cn, and if you take some Bn of similar type, then they will converge to same limit. Does
Yes, sir.
that imply that the sequence that f of x exists limit? You have shown only for two particular sequence, right? It should be for
Yes,
any
sir.
sequence. So when you say the limit exists by sequential criteria, okay, so
Yes, sir.
you have to show for any arbitrary sequence. That's not possible always, right? For
Yes, sir.
that you have to use epsilon delta definition. But when you
Yes.
want to show the limit does not exist, there you can show by choosing some particular sequence. Is it clear?
Yes, sir.
So if you want to show the limit exists, then it's very difficult using sequential criteria. But if you want to show the limit does not exist, there it is useful. Okay. So you have to choose either one of them, either some sequence which converges to C, but f of Cn diverge, not exist. F of Cn diverge, or you have to choose some sequence Cn Dn converges to C, but f of Cn, f of Dn converge to different limits. So this sequential criteria is useful when you want to show that limit does not exist. Okay. So any doubt? Similarly, already you have seen sandwich theorem, right? Suppose two sequence converges to same limit, then if you take some in between sequence, its limit will also converge to the same value. Okay, so how will write it? I will write suppose f g h so D is like some domain, subset of R. Okay. So what will be condition if f of x less or equals to g of x lesser equals to h of x. For all x belongs to. So here we have to see that limit extends to c. So that means we don't care what is happening at exactly c. So that's why we have removed from the domain. Now, if limit extends to c, so this is an both. So this should be, and if limit extends to c f of x equals to limit extends to c h of x equals to L, then what is your conclusion? The limit extends to c g of x equals to L. You have already studied this, right? Is this theorem clear? Or if you have any doubt till now? Is this theorem clear? So similarly, you have already studied in sequence, right? Three sequence A and B and Cn. If A and Cn converges to some value, then Bn will also converge to the same value. Similarly here, three functions, the first and the last one. So that's why it's also called quiz theorem. Okay. So suppose limit x tends to 0, x cos 1 by x. Okay. So does this limit exist? Does this limit exist? Suppose you have to show using sandwich theorem. So what will be the limit? What will be the limit? These are the trivial example, okay? What will be the limit?
Sir, 0.
How will show it? How will show it? So in this interval, so here we'll choose some x not equals to 0, okay? In this interval, what will be the bounded this by which value? This is bounded by which value? So suppose this is already true, right? Is it clear? For all x in D, minus 1 lesser equals to cos 1 by x lesser equals to 1. Is it clear?
Yes, sir.
Suppose now you multiply both sides by x. So what will happen? X cos 1 by x. Okay. So this is for x positive. Similarly, for x negative, what will happen? This is for all x positive. Now, if for all x, if it is negative, what will happen? This inequality. How will write from here to here for all x less than 0? If we multiply, what will happen? What will happen?
Sign will change.
Yes, sign will change. So we'll write x lesser equals to x cos 1 by x lesser equals to minus x, right? So together, how will write it? Together, how will write? These two together, how will write? Hmm? These two together, how will write? Yeah, tell me these together two, how will write? Is it so difficult? These two inequality together, how will write? Here minus x lesser equals to x cos x lesser equals to x when x positive, and when x negative, x lesser equals to x cos x minus x. So together, how will write? We have already studied the absolute value function, right?
By using mods.
Yes. So minus mod x lesser equals to x cos 1 by x lesser equals to mod x. Okay. For all x not equals to 0. Now, what will be the limit? Now, what will be the limit? Now, what will be the
0.
limit? 0, right? Because
Yes.
limit x tends to 0 minus mod x is
Both
0.
of the function approaches to 0.
Yes. And limit x tends to 0 mod x equals to 0. So by Sandwich theorem, limit x tends to 0, x cos 1 by x equals to 0. Is not it? So this is exercise, huh? Similarly, you can show for limit x tends to 0, x sin 1 by x, huh? X not equals to 0. Okay. So till now any difficulty? So we have started limit using sequential criteria. And that criteria is useful when you want to show that some limit does not exist. Then we have used Sandwich theorem, and also you have seen algebra of limits. Now using epsilon delta. So earlier we have taken one example, right? What was that? F of x equals to, yeah, x plus 1 and 5 at x equals to 1. So we have taken this example, right? 2x plus 1 and 5. So this is so nearby at x equals to 1, the value of the function is equals to 3 that you have to show. So if you want to show by sequential criteria, you have shown that for any arbitrary sequentials, we have not chosen any particular, for any arbitrary sequence. But it is very difficult, right? So this is just theoretically. Now if you want to show, suppose epsilon delta approach that you have already studied. So in the epsilon delta approach, you should first know where it converges, right? So what you have to show, if you want to apply this epsilon delta criteria, what you have to show, that for a point x near 1, f of x, what will be the expected value of f of x is? F of x should converge to would be 3, right? So you have to show this one. So in the epsilon delta approach, first you have to know the limit, right? What do you want to find? So limit x tends to 1, f of x equals to 3. So if you want to show by epsilon delta, how will show it? I'll show it. For x sufficiently close to 1, f of x should be arbitrarily close to 3. That you have to show, right? For x sufficiently close to 1, you have to show that f of x is arbitrarily close to 3. That you have to show. So how will you show it? F of x minus 3 is nothing but your 2x minus 2. Is not it? Is it clear?
Yes, sir.
And this value should be less than? This value should be less than? I have not write the epsilon delta definition, but you can tell me. I'll write now. So I'm first trying to show by definition. So this value should be less than?
7.
Huh?
7.
7. This value should be.
Sir.
That means less than epsilon, right? That means less than epsilon. Is not it?
Yes, sir.
So
Yes, sir.
here epsilon is arbitrary. So we have to show that given any epsilon positive, we have to find a delta positive, right? Such that when 0 less than x minus 1 less than delta, we have to find f of x minus 3 less than epsilon. Is it clear? So what you have to choose here, delta? What you have to choose here, delta? So this you have to show, right? That means this should be, this is already, if you want to show that this is less than epsilon, what you have to choose here? What you have to choose here? And here you have seen that we have used 0 strictly greater than mod of, because in limit we don't care what is happening exactly and at the point 1, right? At the point C in your definition. So this we have to show that this value is less than epsilon, right? That means this value that you have to find. So your delta should be what? Your delta should be, you cannot see from here what is your delta. Delta should be
mod fx minus 3.
no delta. From this relation, delta should come in terms of epsilon.
Mod 2x 1.
Wow. This should be, see, we have to, so given any arbitrary positive epsilon, we have to show, we have to find a delta such that this value is less than epsilon, right? So what should be your delta? Already have shown here. less than epsilon. From here you cannot find a 1 delta, which
Sir, epsilon upon 2.
yes. So we have found 1 delta positive, right? We have found 1 delta positive. 1 delta is sufficient, right? We have found 1 delta positive such that f of x minus 3 less than epsilon. This already you have studied, right? So how will write the definition? I will write the definition. I will write the definition. Can you write on your own the definition? Can you write on the definition? So this you want to write, right? Using epsilon delta, how will write it? This already I have written, right? Like that. So when x is arbitrarily close to C, f of x should be arbitrarily close to L. That you have to show. So given any P assign positive epsilon, there should be there exists a positive delta, right? Such that f of x minus L less than epsilon, right? Where x will come from this C minus delta and C plus delta neighborhood. And you have to ignore the point C. Is it clear? And when this, if the value at C exists, and if this equals to your FCL, then later on you will see that f of x is continuous at the point C. But first, let me know that whether this definition is clear or not. So what should I write? Given any there exists a positive delta, right? That means delta should be positive. Such that what will happen? Such that what will happen? Such that what will happen? What I should write? What I should write? Is it too difficult? Is it too difficult? That what I should write? F of x minus L less than epsilon, right? That means L minus epsilon less than f of x less than L plus epsilon. For all x just to here. So you are taking, so this is delta neighborhood of x, right? Is it clear? So this definition we can make complicated by using the limit point, but I have not told you what do you mean by limit point. So for the time being, just use this definition. So here C should be limit point of the domain. So I have not talked about limit point. So Is this definition clear? This already have seen in case of sequence. Similarly, what is the difficulty? So suppose you have to show limit x tends to 3, 4x minus 5 equals to 7. Okay. So this is 3. So how will show it? How will show it? How will show it? So what will be your relation between delta and epsilon? What will be your relation between delta and epsilon?
Delta is equal to epsilon by 2.
You have to check, right? So given any arbitrary positive epsilon greater than 0, we have to find a delta, right? Such that you have to see this should be less than epsilon, right? Whenever so what you should choose as delta? What you should choose as delta?
Epsilon by 4.
Yes, epsilon by 4. So this inequality you have seen, right? 4x minus 12 less than epsilon. That you have to show. That means you can see here what you have to check. Delta equals to epsilon by 4. If you take, so you have find a positive delta such that whenever you choose delta this and whenever this x lies in this neighborhood from here, right? So here x belongs to 3 minus delta, 3 plus delta minus the point 3. So this is one interval 3 minus delta to 3 plus delta and 3 is excluded. Okay, 3 is not in there. So you have find one delta such that this relation holds, that f of x minus L less than epsilon. Is it clear? Now if you approach, so in the real line you can approach any point either from this or this, right? So one-sided in the real line, right? So one-sided limit. What do you mean by one-sided limit? What do you mean by one-sided limit? That your left hand limit and right hand limit, that already you have studied, right? If we approach
Only
the,
one side is defined in their domain.
yes. So you can see that when c minus what delta, right? Less than x less than c, what will happen? When c less than x less than c plus delta, what will happen? Okay. So this is your left and this is your right. Is it clear? So,
Yes, sir.
so similarly using F sequential criteria also you have shown that one-sided limit, huh? I will write. I will write. Suppose we have to write left hand limit. I will write in both approach left hand limit. So using sequential criteria, how will write left hand limit? That limit extends to c minus f of x equals to L. How will write it? How will write it? How will write it?
F of x minus delta is equal to L.
So in sequential criteria, how will write it? That for any sequence Cn, right? For any sequence Cn, such that Cn should be less than C and Cn tends to C. Is not it? We have for any sequence, we have f of Cn converges to L. And in terms of epsilon delta, what we should write? In terms of epsilon delta, what we should write? In terms of epsilon delta, what we should write? If for every epsilon positive, there exists one delta positive such that C minus delta less than X less than C implies f of X minus L less than epsilon. Is it clear? So if you take for suppose some functions, some AB2R, okay, suppose or any form interval R by subset of R. Suppose this closed interval, this you already know, right? What do you mean by this? Do you know what do you mean by this, right?
Yes, sir.
Is it okay? So suppose you know left hand limit and right hand limit, right? So suppose f of a to b for some function, and C belongs to this interval. Okay. So then limit extends to C, f of x exists and is equals to L. If and only if, if and only what we should write in terms of right hand limit and left hand limit. If and only both. If and only both, limit extends to C minus f of x and limit extends to C plus f of x exist and R equals to L. Is it clear? So if both left hand and right hand limit exist and equal to the same value L, then limit extends to C f exists and equals to L. So if and only both way is true. Okay. So both way is true. Till now you have any doubt? Till now you have any doubt?
Sir,
Hmm.
sir, can you please share the link of this notebook that you have created so that we can access it?
Okay, this lecture. So I have already used to share your videos, right? So you need also this one?
Yes, sir.
Okay, okay, I'll send you. So before lecture, so from lecture 1 to lecture 4, that we have written in Microsoft Whiteboard. I don't know how that can be shared. Already you have video, right? But from lecture 5, there is no issue. But Microsoft Whiteboard, that I have used to write in there, right? First 4 lectures. But you can look at the video, okay? For first 4 lecture. And in the video lecture, you can see, every day. So there should be no confusion. Okay. So which one is first, which one is second, that should not be your problem, right? Okay.
Yes, sir.
So you have any class? We'll continue here, right? So once you understand what is we mean by limit, then you can study properly what do you mean by sequence. That L should be equals to your f of C. In case of you want to show by limiting approach continuity. We'll see, we'll discuss quantity in next class, okay? Okay, see you tomorrow.